Hello everyone. In this set of videos, we are going to talk about sensor programming. Up to this point, we have learned how to program output devices such as motor and LED. With that knowledge, we now can control the actions of the robot. But to make robot intelligent, we must provide it ability to understand its surroundings. And that is possible if we provide robots ability to sense. That's where sensors play an important role. They help robot to get understanding about surrounding conditions and thus help them in making decisions. Before we talk about how to program sensors, let's first understand what are sensors and what is their general working principle. At high level, sensors can be categorized as resistive sensors and capacitive sensors. Resistor and capacitor are two electronic components. So based on which of the components we use for sensing, we categorize these sensors as resistive or capacitive sensors. Now we know from Ohm's law that if we keep the voltage constant, then the current is inversely proportional to resistance. So this is a simple circuit where across these two ends of resistor we have applied a voltage and that results into a current flowing through it. In case we increase the resistance, then the current will reduce, and this change is proportional, which means if resistance is doubled, current is halved. And that is what Ohm's law tells us, and that is what we use in getting the resistive sensors. So what we have is we have some materials whose resistance changes with change in temperature or light or pressure. And using this ability of this material to change its resistance according to change in temperature, light or pressure, we create resistive sensors because the change in resistance results in change in current, and that change in current is what we monitor to get idea of how much change there has been in those specific parameters like temperature, light or pressure. For example, we have a material called velostat. It's made up of some carbon compound, and if we press this material, then the resistance of the material reduces. And we know as the resistance will reduce, the current will increase. And this increase in current gives us idea that there has been some pressure applied on the material. And that's what helps us to create a pressure sensor. Similarly, we have temperature sensors and light sensors where those materials change their resistance when there is a temperature change or there is light change. One example is LDR, light dependent resistor. LDR is used in making the light sensors. And all these type of sensors which use the ability of the material to change resistance based on the changes in various surrounding conditions are called resistive sensors. Now let's talk about capacitive sensors. For that, let's first see how a capacitor is made. A capacitor has two metal plates. And a dielectric material is sandwiched between those metal plates. A dielectric material is mainly an insulating material. When a voltage is applied across these two ends of capacitor, all the positive charges get accumulated on one metal plate and all the negative charges get accumulated on the second metal plate. And that ensures that this capacitor holds charge. Now we will not go into detail of how the capacitor works, but let's understand that capacitance of the capacitor C is equal to epsilon A upon D. Now what is epsilon? Epsilon is the dielectric constant. A is area of these metal plates. And D is the distance between those metal plates. So this capacitance of a capacitor can be varied by variation in these three quantities. Let's first talk about area. We know these are metal plates. So when they are exposed to a temperature, metals expand. So the area of the metal plates is going to increase. With increase in temperature, the area of the metal plates is going to increase. And if the area increases, you can see area is in numerator, which means the capacitance will increase. If rest all is constant, area increases, capacitance will increase. And that will indicate that there has been increase in temperature. And we can calibrate that increase in temperature to the increase in capacitance in such a way that we can use it as a sensor. Another thing is distance between these plates. So if I apply a pressure on these plates from both sides, what's going to happen? They're going to come closer. The distance is going to reduce. Distance is in denominator here. If it reduces, the value of capacitance is going to increase. So which again indicates that there has been some pressure applied. So capacitance increases. We know that there is some pressure which is applied. That's why the capacitance has increased. So when we create the pressure sensors, we use the ability of capacitors to change the distance between the plates. Third is dielectric constant. Every dielectric material has a specific dielectric constant. So air has some number, paper has some number, liquids, oils, they have some other number, vacuum has some other number. So different dielectric materials will have different dielectric constant. Let's assume I use paper as a dielectric material, and paper will have its own dielectric constant, and hence we know the value of capacitance. Now if we put this capacitor in any place where there is moisture, that moisture will be absorbed by the paper, and now the dielectric material is not made up of paper only, but it is made up of paper and water. And hence the dielectric constant of that changed material, initially it was paper, now it is paper and water, the dielectric constant will be different, and hence the capacitance will be different. The capacitance will change, and more moisture is absorbed by the paper, the change of capacitance is going to be more. And knowing the relation between them, we can use this capacitor for sensing the moisture content in the air. or moisture content around it. And we can create a moisture sensor using such kind of capacitor. Now, I hope we understand that by varying these three parameters of capacitor, which are dielectric constant, area of metal plates and distance between plates, we can get different types of sensors. And the sensors which use capacitors for sensing the surrounding are called capacitive sensors. So we have gathered some basic knowledge about the sensors, how the sensors are made, and in our next video we are going to talk about the basics of sensor programming.